All right, so in your notes, what I need you guys to do is label them Pythagorean Theorem Identities. I think this goes to section 3.3. Pythagorean Theorem Identities.
Would it be like 4-3?
No.
I mean 4.3. I'm sorry, yes, 4.3, Pythagorean Theorem. Identities. And the first one says that if you have the sine value squared of, does it say theta on your paper?
U.
It says u, sine squared of u. Again, I don't know why it says u. You can use x's, you can use thetas, whatever's comfortable to you. But on your paper it says this. And I kind of just showed you guys where that came from. That's really just taking the x squared. The side a squared plus b squared is equal to 1 squared, which 1 squared is 1. That's where the 1 comes from. But what I want you guys to recognize is that if we were to start moving things around here, put a box around this. This is kind of like the big head honcho Pythagorean Theorem identity. But if you were to, using this identity, if you were to subtract the sine squared of u from each side, you would have that the cosine squared of u is equal to 1 minus the sine squared of u. Are you okay with that? All I did was just subtract. And you guys will see where I'm going with this in a minute, but can you accept that? If I just take the sine squared and move it to the other side, I would have 1 minus the sine squared of u.
Yep.
Okay? Put a box around that. That's going to be good information. Now I'm going to go back and I'm going to get rid of this subtracting the sine squared, and I'm going to subtract cosine squared of u, and then I'm going to subtract the cosine squared of u over here. So you are going to be left with the sine squared is there, so I'm going to have the sine squared of u is equal to 1 minus the cosine squared of u. That is pretty much the same identity, just written another way. So my point is this: if you ever see in a problem that you have 1 minus the sine squared of u, what is that the same thing as? It's the same thing as the cosine squared of u. What if you see 1 minus the cosine squared of u? What does that really mean? It means sine squared of u. What if you see sine squared of u plus the cosine squared of u? What is that equivalent to? 1. And you'll get good at recognizing these things as we work through some of these kinds of problems. All right, what I would like you to do now is go to the second Pythagorean theorem identity, which says 1 plus the tangent squared of u is equal to the secant squared of u. Put a box around to that because that is the main tangent squared, secant squared identity, but we're going to build some things off of this. So the same thing that we just did, let's leave the 1 there. Let's get rid of the tangent squared of u. Get rid of move it so that the tan squares will cancel out. You'll be left with 1 is equal to secant squared of u minus the tangent squared of u. Are you okay with that? So if you ever see secant squared of u minus the tangent squared of u, you will know that you can replace that with a 1. All right, let's do the same thing with the 1. Let's get rid of the 1. So I'm going to cross that off. I'm going to subtract 1 from each side. So I'm going to have the tangent squared of u is equal to the secant squared of u minus 1. That means the same thing too. These are all built off of the 3 Pythagorean theorem identities that are listed on your pink paper. One more. 1 plus the cotangent squared of u is equal to the cosecant squared of u. Now, on on the test, let's talk about the test for a minute. I am not letting you have all of these variations in front of you. You will have just those three. But you need to know that if you moved things around, you would come up with the things that we're coming up with right now.
Yep.
Okay? Alright, so put a circle around this. Go box around it. And let's do what we did. Let's get rid of the 1 first. I'm going to subtract 1. I'm going to subtract 1. The cotangent squared of u is the same thing as the cosecant squared of u minus 1. Put a box around it. But we also could keep the 1 there and move the cotangent squared to the other side.
The co-teach.
Yes, thank you.
Anytime.
So I'm going to move cotangent squared of u to the other side. So I'm left with 1 is equal to the cosecant squared of u minus the cotangent squared of u. There's our third identity. Now, I want to talk to you guys about this. If you have the sine value of x squared, the sine value of x squared, that is exactly the same thing as taking the sine squared of x. Those things mean exactly the same thing. Why? I don't know. You just need to know that these things, for some reason, it is acceptable to put the squared there. If you ever need to use your calculator to square a sine value, then you need to type it in the first way. The sine of some value in parentheses squared on the outside. Your calculator will not allow you to put the 2 in between the sine and the x, okay? So if you have the cosine of x squared, that's the same thing as putting the 2 in between the cosine and the x. Like I said before, I don't know why, but it's just always acceptable. So if I go back to this, all of these like cosecant squared of u, that right there really just means the cosecant of u squared. I just want you to know that that's what that means, okay? All right, I gave you guys this piece of paper called Notes, the Basic Trig Identities.
Yeah.
And the very first problem says this. I do know we're running out of time, so just bear with me here. I'm going to use x's instead of thetas, because I think x's are so much nicer and easier to write than thetas. So by all means, if you want to do that, go for it. But this is what you see in front of you. And your job is to try to get, your job is to kind of treat this like it's a puzzle. You need to try to get the left-hand side of this to look like the right-hand side. So the left-hand side has a bunch of junk in it, but the right-hand side just has a 1. You need to try to change things around on the left side to make it match the right side. So what does secant mean? That's when you got to use that pink trig cheater thing. And you got to decide what on there, what do you think I could do? What can I change about the secant so that ultimately when I multiplied it by the sine, I would get 1? What does secant mean? Does it say secant or theta?
Yeah, secant theta. Yeah, that's right.
Sine.
Okay, this is supposed to say tan. My bad. It's supposed to say tan of x, not 1. I'm sorry.
Okay.
What does secant mean?
The reciprocal.
Okay, the reciprocal of cosine. So if I did 1 divided by cosine of x, if I replace the secant with 1 divided by the cosine of x, and then I multiplied that by if I kept the sine of x the same, so really I'm just multiplying secant times sine. Secant means 1 divided by cosine. If I multiply that by the sine of x, what I really have is 1 times the sine of x, which is the sine of x divided by the cosine of x. What is the sine of x divided by the cosine of x? It's tangent. So what you've just done is you've made the left-hand side look like the right-hand side. Let's try another one. Let's go to number 2. Number 2 says the cosine of x times the tangent tangent of x, and we have to try to make this, say, the sine of x. Cosine of x, I'm going to keep it the same. Tangent. What can I do to tangent? What does tangent mean?
Sine divided by cosine.
Sine divided by cosine. So I'm going to rewrite this tangent as the sine divided by the
Cosine.
cosine.
Do they cancel
The
out?
cosines cancel out. What do you have left?
Sine.
Sine of x is equal to sine of x. So these are kind of like puzzles. You have to try to get the left side to look like the right side. I want to go over, let's go over number 3, and I got 1 minute. Hang in there, you guys. Please, please, please. Tangent, let's go. We got tangent squared of x minus the secant squared of x is equal to, we got to try to make it look like -1. Go to your notes that you guys just took. What does secant squared of x mean?
Yeah.
Secant squared means
Minus. Oh, tan
1
squared?
plus the tangent squared. That's right on your pink. That's
Yeah,
right on your
1
pink
plus
paper too.
tangent
1
squared.
plus the tangent squared.
Yeah.
So what I'm going to do is write this as the tangent squared of x minus. I'm going to replace secant squared with 1 plus the tangent squared of x. You okay with that? I have taken secant squared, replaced it with 1 plus the tangent squared. And now what I need to do is multiply that -1 into the parentheses. In other words, I'm just distributing a negative in. That shouldn't be a big deal. So we have the tangent squared of x minus 1 minus the tangent squared of x. Are you okay with what I just did? The tangent squared of x and the minus tangent squared of x, they cancel right out. What are you left with? You're left with a -1, and isn't that what you wanted? Thank you for hanging in there, you guys.
No. Oh.